So in question 4, we're asked to show that these two curves of the equation all meet for all values of k. So what we can do simply is rearrange this second equation in terms of y only, so we can solve for y basically, and say that this will be minus 3x minus k. And what we can do is plug this into this y, basically making the two equal, and we will be able to solve for when they meet. So we're trying to find their intersection. We're trying to find that they intersect for any value of k. So if we just plug this formula inside of here, we have minus 3x multiplied with minus 3x minus k minus 40 is equal to 0. So we can simplify this. So this is going to be x squared plus 9x squared plus 3kx minus 40. This will be 0. And then we have a 10x squared plus 3kx minus 40 is equal to 0. And we need to see for what values of k this formula is true. So for which values of k will this equation be equal to 0? What we need is that for any value of k, we will always have a root, basically. What that means is that if this is yx, then our graph always needs to pass through the x-axis, meaning its determinant has to be positive, right? That means it always has two solutions. We need the determinant to be positive. Now the determinant is b squared minus 4ac. This has to be larger than 0, so there's just 9k squared plus 1600, just to be larger than 0. And well, what we see here is if we subtract 1600 and divide by 9, we have k squared is larger than minus 1600 over 9. And this is indeed always true, as k squared is always a positive number, and therefore it will always be larger than 1600 over 9.